Hello everyone, this is Mrs. Lindsay. Today we're going to talk about angles, but before we do that, I would like you to pause this video, try the warm-up, and push play once you're done so you can check your answer. Okay, so I got x values of -4 and 2. Important thing to notice here is I did not assume that PQ is congruent to QR because we don't know it's the midpoint. So the only thing that we can do, the only thing we know is that PQ plus QR is equivalent to the whole segment PR. So that's the actual equation that I set up. Now remember, just because x is negative doesn't mean that it doesn't work. You need to check both. So I plugged that in to QR and PQ, but as soon as I plugged in -4 to QR, I get a negative value. Therefore, I knew that -4 value would not work. So, plugging 2 in, I got QR to be 8, PQ to be 7, therefore it is not a midpoint. Alright, so let's go ahead and start angles here. So we're going to work with congruent angles, classifying angles, naming angles, and angles that are bisected. Okay, so we have the What Am I worksheet here. So what I would like you to do is go ahead and take a look at these and fill those in. Again, pause the video, fill those in, read the descriptions, and then push play once you're done to check your answers. Okay, so I'm made up of 2 rays. Both rays have the same endpoint. The common endpoint is called the vertex. My 2 rays are called sides, and there are many ways to name me, which we'll get to on the next slide. A number placed inside me near the vertex. By a single letter naming the vertex. This is a special case that we're going to definitely discuss here. And 3 letters following this sign. And please note, the vertex letter must be in the middle. So when I'm taking a look here at these examples, so if I have this angle, there is only one angle here as well as this one. There is only one angle there as well. So when I name this, I can use one single letter to name both of those angles. Okay? But again, please notice the vertex must be the middle letter. Okay? Must be the middle letter. Now this one below has a number in it, so I can also use that number. Okay. Again, special case with using just one letter. We cannot do that over here because there are actually 1, 2, 3 angles. So we have angle 2, angle 3, and then we have the larger angle KBM. So if you write angle B, we do not know which angle you're referring to. Okay. Alright, so let's move on here. Using the following diagram, we want to name 2 pairs of congruent angles and use a congruency statement. So this is similar to what we did with segments. We are looking for lines or markings that are exactly the same. So here we have a marking, 2 squiggles with a line through it, so those 2 angles are congruent. And again, realize I cannot say angle P. I must use 3 letters. So I'll use MPA, and that is congruent to angle CFG. Okay, so let's see if there's anything else, and I believe there is. Yes, this would be this angle right over here. Again, with this angle, so angle AMP. And that is congruent to angle FGT. Alright, moving on to B. What is another name for angle 2? And we have a couple options here. So here's angle 2. MHP, or we could also do MHA. We can also reverse the order. AHM and PHM. Any of those will work. So angle AHM. Okay, couple definitions here. if you want to go ahead and pause this so you can write these down and then resume, that would be fine. But here we have an acute angle. An acute angle, most people would say it's less than 90, but you can't forget that it is also greater than 0. Obtuse is greater than 90 degrees and less than 180. Right angles, which we referred to already, are 90 degrees, and straight angles are 180 degrees. And these should actually be reviewed from earlier as well. Congruent angles, angles that have the same measure, as well as an angle bisector, which is a ray that divides an angle into two congruent angles. So again, a ray divides it into two congruent angles is an angle bisector. Okay, so let's try a few examples here. Name the congruent angles. So all we know in part A is that ray RO bisects angle NRP. So we only know something about this angle here. So if it's bisected, those are congruent. So you could say angle NRO is congruent to angle PRO. Moving over to B. Here we have ray XT and ray XV trisect angle SXW. So this larger angle, and again, that's the only thing we know. So these three angles would then be congruent. So I would have angle SXT congruent to angle TXV is congruent to angle VXW. Okay. 3. We're going to skip B, but we'll do A. It says name the angle bisector. Okay, so we have this congruent over here. So it bisects it, so we'd have JG, and that would be a ray. And again, I said we were going to skip B, but we'll go ahead and do it. So we have POK is congruent to MOK, so again, these are congruent. So in this case here, we have OK is the angle bisector. Now let's put some degree measures to this. So in part A, we have 60 degrees. So let's see here. We have angle XTZ. We want to find that if TZ, the ray TZ, bisects angle XTY, and XTY equals 60. So this whole angle here, this whole angle is 60. So if that's bisected, these are congruent, so we can just half 60. So XTZ would then be equal to 30 degrees. We are also going to skip D here. We have not done minutes yet, but I would like you to pause and go ahead and do C, and press play when you're ready to continue. Okay, 18.25. Alright, now for the next several problems. You're going to see that this is the exact same diagram. The given information is different. So, really important, as I've always been saying, take your given information, mark it on your diagram, and then let's try to come up with an equation. So here we have angle EBC is a right angle. Mark that on my diagram. Measure of angle EBF, so this angle right in here, is 6x plus 3. Mark that. Angle FBC is 4x minus 1. We mark that. Again, let's pull an algebraic equation off of here. So I see that I have a right angle, and these two angles, EBF and FBC, make up this right angle. So they would add to 90 degrees. So 6x plus 3, 4x minus 1 equals 90. Now I have an equation I can solve. So I'll get 10x equals 88. And then if we divide, get that to be 8.8. Okay, and just like all of our problems here, just because we found x, that doesn't mean we answered our question. Let's go back and read it. we want to find the measure of angle FBC. So we need to plug in 8.8 into 4x minus 1. So using our calculator, we get that to be 34.2 degrees. Okay. Let's go ahead and try the next one. Alright, given different information here, BF bisects angle EBC. So from that, I can mark these two angles are congruent. Now I also have angle FBC is 3x plus 2. Mark that off. And then we also know angle EBC, the larger one, is 9x minus 1. So I'm going to kind of just mark that just like this, because again, that can get a little bit confusing. So EBC is 9x minus 1. Well, okay, so where's our equation? We know these two angles equal or add up to EBC. We also know they're congruent, so this angle would also be 3x plus 2. So if I add those two together, or in other words, double 3x plus 2, I can set that equal to the larger angle, 9x minus 1, and then solve that. So again, distribute through, use our algebra here, solve for x. So we get 5/3 equals x. Again, is that what we're looking for? Well, we're looking for angle EBC, the larger one, so we can simply plug that into 9x minus 1 and get that to be 9. Okay, I would like you to actually pause this video, try number 7 and number 8 on your own, and then push play to check your answers, and then we'll do the last one together. Okay, so here is the answer for number 7. Again, please make sure you're labeling the diagram, and this one, it's key to remember a straight angle equals 180 degrees. So I did angle ABE, which is 9x minus 2, plus angle EBC, which is 4x, add up to that straight angle of 180. Solve for x. And then 8. And this one, these two angles added up to angle DBC, which is 115. Alright, so let's tackle this last one. B and C trisect AD. Very careful. This is a segment, not an angle. So these are three congruent segments. AD is 12, and hopefully again you see, since it's trisected, each of these would then be equal to 4. So AB would be 4, AC would be 8. Okay. If AB equals x plus 3, so in other words, that would also be equal to 4. X would then be 1. So then I can find AE by simply plugging in 1 and getting that to be 9 for segment AE. And last but not least is B, the midpoint of AC. So again, if I kind of just ignore CD and I'm just simply looking here at AD, as our AC, yes, this is 4, this is 4, so that would definitely be yes. Okay, so this concludes our section on angles. So refer to your calendar for the homework for angles.